First thing we're going to do is we're going to recognize and graph periodic and trigonometric functions. Periodic functions are functions that repeat exactly in regular intervals called cycles. The length of a cycle is called its period. Examine the graphs of the periodic function and the non-periodic function below. Notice that a cycle may begin at any point on the graph of the function. So this problem here, this is a periodic function because you can see that it just keeps repeating and repeating itself. This one is not. It doesn't, it's getting bigger and bigger and bigger. So this is not periodic. Now, to find the period, what I always do is I always just start at a point, and then I trace that function until I get to that same point again. So now I'm right back where I began, and then I would do this exact same thing. I could go, so this is called the period right here. How far do you go before you repeat yourself? And in this problem, it looks like the period is 2. And you could do that from here to here, that's 2. You could do it from here to here, that's 2. So it's always repeating every 2. Now in this problem, it says which function has a period of 4. All right, so if I start right here, I go up, and I come down, and then it looks like I'm going to start all over again. So I'd go up, right down. So this is the period right here. 1, 2, 3, 4. So this one has a period of 4. Now this one starts way over here, goes, and then it's going to go back down. So the period would be, what, 8 here? So finding the period is not that difficult if you have a periodic function. Which function has a period of 2? Okay, so if I took a look at, I'm just look at this one, go from here to here, and then it repeats, so it looks like this one has 2. This one here, that's way more than 2 because it's going to start like there, and it's going to keep going. So that one has way more than 2. This one has a period of 4. This one has a period of, let's see here, so if I start way up at the top here and go to way up at the top here, looks like 1, 2, 3, 4, 5, 6. So this one has a period of 2. The characteristics of the sine and cosine function. Now there's more trigonometric graphs. You've got the tangent graph, the cosecant, and all that kind of stuff. We are only going to focus on sine and cosine in this class. Okay? The sine graph starts at 0, goes all the way up to +1, comes back down, goes to -1, comes back up. So that is one period. What is a period for the pi or for the sine function? It is 2 pi, because if you see here, this is pi, 2 pi. So the sine function, the period is 2 pi. The domain is all real numbers. You could put anything in there. The range, though, is between -1 and 1. Cosine function looks exactly like the sine function if you just shifted it over. If you started right here, this is basically the sine function, right? But it doesn't. The cosine function starts at +1, goes down to -1, goes back up to +1. So it starts at 1. Sine function starts at 0. The domain is all real numbers. The range is everything between -1 and 1. And the period is 2 pi also for the cosine function. Very important to know. Now, we can, if we know what the parent function is, we can shift the graph left and right, up and down, just like we do with any graph. For example, remember back when we were doing functions, quadratic functions, and we said that this is the parent function. That should have gone to 0 here. And this was y is equal to x squared. And then we said, okay, what happens if we add 1 to this? Well, it shifted the graph up 1 unit. Well, if I have y is equal to the sine of x, the sine function looks like this. If I added 1, oh, now the sine function is going to just shift up 1 unit, and it would look like this. So the transformations are exactly the same when you're dealing with all these different types of functions. That's why it's so amazing when you learn them. It's like, oh man, this is pretty easy. Now remember when we did quadratic functions and we did something like y is equal to x minus 2 squared. What did this do? Well, it shifted the graph 2 places to the right. So now my quadratic would be 1, 2 places over here. It would look like this. Well, guess what? If I did y is equal to the sine of x minus pi, guess what? It's going to shift my graph pi units over, which is a little bit harder than shifting 2 units over, but it's just going to shift this graph over pi units, so it would look like this now. So all of the transformations that we did in the past are going to come back again. Now, this is a kind of a standard form. It's not really the standard form, but this is the one that we're going to use right now. The number in front, so a sine b x, this is the amplitude. Remember, if I just gave you the sine of x, how high did that graph go? Well, it went up to 1, came down, went to -1. Now, if I put a 2 in front of here, it's going to go up to 2. It's not going to, so it's going to go up to 2, it's going to go down to 2, and then back up. So this number is called the amplitude. It's how high the graph is going to go. Well, not really, because if you shift up units, but this is, you know, instead of 1, it's going to be 2 now. The b value in front here, this number here, tells you what the period is going to be. If this was just a 1 in front, the period of this function would be 2 pi, like we said before. But if this number is other than 1, then we have to use this little formula right here, 2 pi over the absolute value of b, and that gives us our period. So if I had something like the sine of 2x, okay, if I put that in here, the period's no longer 2 pi. If I put 2 in here, the period is now pi. So when I graph this thing, the normal graph, so this would be pi over 2, this would be pi, this would be 3 pi over 2, this would be 2 pi. The normal graph would look something like this. It would go up, come down, go up. Now, if I was going to graph the sine of 2x, now the period's just pi. So this is pi right here. So that means this graph is going to be, it's going to go up, it's going to come down, it's going to come back up. Oops, it kind of messed that up a little bit, but it's going to just shrink it in. It's going to be a lot smaller of a graph. Okay, so how to find the period? Just 2 pi over b. So if I was going to graph this problem right here, what is the amplitude? The amplitude is 3. What is the period? Well, the period is 2 pi over 2, which is pi. So the period is pi. So now, if I was going to graph this, usually my graph goes out this far, right? My sine graph. I'll graph the normal sine graph. So let's count by, let's say that this is, we'll go by 1. So this is 1, 2, 3. So if I was going to graph this thing, I know at pi over 2, then at pi, 3 pi over 2, and then up. So my graph is going to look something like this. I'm going down too far. Boom, right there. That's my sine graph. Now I'm going to graph this one. So now my period is pi. So right here. So I always break it up into 4 points. So 1, 2, 3, 4. So this will be the highest, and my amplitude is 3. So now it's going to go up to 3. It's going to hit 0. It's going to go down to 3. And then it's going to go to pi. So my graph is going to look like this. Up. Boom. And then it would continue. I mean, I would go up, down, up. Okay. But now that the whole sine graph is, the period is pi, so it's going to just really basically condense it. Awesome graphing. I love these things. What if I asked you to graph 4 cosine of 2x? Okay, so cosine now starts at 1. So I'm going to graph the normal cosine graph so we can see what the difference is between the cosine. So cosine would start here, and then goes down, and then it comes back up. So it just goes to 1. So it's going to look like this. And it would continue. Oh, no, no, I'm using, sorry. Oh, no, I didn't want to do that. Darn it. Sorry about that, guys. Kind of messing that up. I just wanted to delete what I had there. Okay. So let's see. Okay. So let me see if I can do this again. So I want to delete that. Okay. So the normal sine graph starts at 1. Then it's going to hit pi over 2, bottom, and it's going to come back up. We'll go here. So my cosine graph would look something like this. And then it would continue, obviously, continue going on. But the normal cosine graph goes from 1, and the period is 2 pi, and then it goes down to -1. But this graph, the amplitude is 4. So now it's going to start way up here. So let's change colors. So it's going to, oh, I take that back. Yeah, it's going to start at 5, isn't it? Because normally it would start at 1, but the oh, I take that back. It's going to start at 4 because we always start at 0, 1, 2, 3, 4. Okay, so it starts at 4. And then my period, again, the formula is 2 pi over b. So now my period is pi again. So my whole cosine graph is going to go from here to here. So I'm going to go up to 4, hit 0, go down to 4, come back up. So I'm going to go down, boom, and then come back up to 4. So it's going to look something like this. Try to draw it as best I can. And then it's going to continue on. It's going to go down. It's going to come back up. It's going to go down. It's going to come back up. And it's going to continue that way. So now this number here is the amplitude. This will tell you what the period is going to be. Okay. Let's try another one. Nope. So now we have to talk about shifting left and right, because a sine and cosine graph can be shifted left and right, just like we did with our other types of problems that we had with like quadratics. We shifted left and right. Remember, if it's plus inside, it's going to move to the left. If it's minus inside, it's going to move to the right. So if I gave you a problem, let's say I gave you something like y is equal to the sine of x. Let's go plus pi over 2. Okay. So when I graph this thing out, not a very good graph, but that's okay. I know 1 is going to be the highest. I know the lowest is going to be -1. So then I always draw out my graph. I always do pi over 2, pi, 3 pi over 2, and 2 pi. I could also do it this way. Okay, it doesn't really matter. Okay, so I'm going to shift my graph I'm going to move it to the left, pi over 2. Well, guess what? This graph starts, the sine graph starts at 0. So I'm shifting it backwards, pi over 2. That's right here. So that means it's going to go up. It's going to come down. So my graph now is going to look like this. What kind of graph does this look like now? So the sine graph shifted to the left, pi over 2. Basically the cosine graph, isn't it? When you really think about it, because it's just shifted pi over 2. So the sine and cosine graphs are basically the same if you shifted them over pi over 2. It's kind of interesting. Okay, now this is the general form for sine and cosine functions. A sine of bx plus c plus d. We know what the a does. It's the amplitude. We know what the d does. The d moves it up or down. Now, this is where it gets a little bit confusing for a lot of students. You always want to have the x plus c. You always want to have a 1 in front of here. So if there's anything but a 1 here, you want to factor it out. So for example, if it was, let's say it was the sine of 2x plus 4. It's like, oh, you know, I don't know how to shift this because there's a number in front. So I factor out a 2. So that's sine 2x plus 2. This is my b value, and now I shift 2 places to the left. So I can bring that b value. I always want to factor that b value out. That way I know how much I shift. Now you can leave it in there, and then you would just shift over this over my b value. That would be how far you would shift. So you can leave it. I always try to bring it out, but it's not that big of a deal. It makes no difference if you leave it. You just have to remember your phase shift is going to be this number over your b value. Okay? And here are some examples of graphs. I just wanted to, you know, you can always use decimals to check your graphs. Sine of x minus 2, well, guess what? Shifted down 2 units. Boom, sine graph goes up 1, comes back down, goes up. So that's the sine of x. So you can always use decimals to check out your graph. 3 sine of x, that means it's going to go up to 3, go down to negative 3, up to 3, so forth and so on. So here's a graph, sine of x plus pi. Well, that means it's going to be shifted backwards pi units. Now pi is 3.14, isn't it? So basically it's shifted backwards 3.14, and then the sine graph starts. Okay, so remember pi is a number. It's 3.14. So if I wanted to graph this problem, and this is very similar to what's going to be on your assessment, it's going to ask you what is the amplitude. Oh, amplitude's pretty easy in this one. Amplitude is 3. What is the period for this graph? Well, guess what? The b value is 1, so it's 2 pi over b, which is just 2 pi. What is the phase shift? Well, the phase shift is left pi units. Left pi. What is the vertical shift? Vertical shift is how far are you going up or down? It's going to go down 2 units. So then you could graph it out. Now that you have all the information, you can graph this function out. So that's very similar to what the whole thing is going to be this week, is being able to graph and being able to just list the amplitude, the period, phase shift, and the vertical shift. All right. Hopefully you guys, if you don't understand this stuff, make sure you come to, well, I would come to Monday's session anyways. Hope to see everyone there. Bye.